Hello everyone. Today we're going to be talking about predator adaptations. So yesterday we talked about prey adaptations. Now we'll talk about the opposite of that, the predator adaptations. So believe it or not, predation is actually an essential part of the balance of the environment and the ecosystem. Uh, Predators usually will choose the easiest meal, and so that means they'll target the elderly, the sick, or the very young. And what this means is that the remaining prey population will be stronger and healthier. Predation is also important in keeping the herbivore populations under control. Um, One example of that is we have deer hunting season around here, right? You try to control the population of deer so that they don't get too out of control, which can affect other things poorly. So you've got to control populations through either predation or by hunting as humans. In order to survive, predators must be able to outsmart their prey and use their advantage of their keen senses, physical adaptations like their teeth and their claws, and as well as the various hunting strategies we're going to talk about today. So when we talk about senses, the first that we might talk about are their finely tuned senses of smell or their vision, their hearing, and they'll tend to be very curious about their surroundings. They'll always be on high alert. When we talk about eye placement, there's a little saying that people like to say, eyes in front likes to hunt and eyes on the side likes to hide. And what you'll see is that eyes in front might not be good as eyes on the side when you want to get a full range of vision, but eyes in front really helps focus on details and judging things such as distance and minute details. And so there are trade-offs to having eyes in front and eyes on the side, but usually what we see is that being a predator, you get your eyes on the front of your face, and being a prey item or an herbivore, you get eyes on the side. Another unique sense that predators have that is enhanced is their sense of smell. They can smell their prey items from sometimes really, really far away. This fox, for example, is hunting, and they are able to smell their prey items up to 2 meters, which is 6 feet under the snow. And so the sense of smell is really important in finding their prey items. Reptiles can also smell, but they smell a little bit different way. They can use their tongue. What they'll do is they'll stick out their tongue and they'll capture particles in the air, and then they'll bring the tongue back into their mouth and rub it against the top of the roof of their mouth, basically. And they have what is called a Jacobson's organ, and the Jacobson's organ allows them to smell the particles that are in the air. And so that's just another way that predators use their sense of smell in order to find their prey. Another sense is hearing, and so you can either hear sort of the way that we do, where we hear acoustics that are sound waves through the air, or one interesting case of hearing is echolocation. Now, bats, they release this high frequency sound that we can't hear, but it bounces off of objects, walls, and prey items, comes back to them, and they can actually see through using this, and they call that echolocation. So that's a really interesting way of using hearing. So let's talk about some hunting strategies. And what we know is that predatory animals have developed various methods of tracking down and killing their prey. Some strategies require more effort, such as chasing, while others require patience and cooperation. And so it really just it comes down to what strategies have evolved in these different hunters. The first one is stalking, and stalking is animals will stalk their prey that have developed special features which ensure that they can sneak up on their prey undetected. They'll have, like cats, will have soft padded paws that might have retractable claws which help them walk silently. Owls have soft, jagged comb-like wings which allow them to fly silently. So this big owl can be flying through the air, but you wouldn't hear it at all. The animals that stalk must have quick reflexes. Once they get close enough to their prey, they've got to bounce on it. They've got to get it quickly to ensure that their dinner is caught. And so this is that universal sign for stalking prey, right? We've probably seen If you've got a cat in your house, you've seen your cat get real low to the ground, the pupils dilate, right? They're stalking. It's a natural instinct. And here are some bigger cats doing that same thing where they get real low to the ground, their pupils dilate, they get real quiet, and they're stalking prey. And so this is the universal sign for stalking. The next is called ambush hunting, or the sit and wait strategy, whatever you want to call it. It requires little energy, however, it does require a lot of patience. Animals who use this hunting strategy usually employ some form of camouflage, right? Whether that be what they look like or how they hide in a tree or if they hide in a burrow. They'll blend into their surroundings and they wait for their prey to come within striking distance and then boom, strike. The one that I want to give you an example is called the trapdoor spider. And so this spider lives in this little burrow that has actually a trapdoor. They'll wait for some sort of insect to come along and boom, jump out of their trapdoor and they will have their prey item. So it doesn't take very much energy, but it does take a lot of patience. Another one for the ambush strategy is this great blue heron. It will stand perfectly still in water for hours at a time and wait for a fish to come by and then strike really quickly and it'll catch a fish. And so this is the ambush strategy or the sit and wait strategy. Another strategy is group hunting. Some predatory animals hunt in groups. They take advantage of their numbers to take down animals that might be much larger than themselves. This method of hunting is often seen in wolves. They have that highly organized pack where they have the method of team hunting where they will surround their prey until there's really no escape. Sometimes the wolf pack will chase the prey in relays. Well, they'll take turns basically until the prey tires out. So the prey just ends up getting too tired to keep running, and they sort of outlast them by attrition. Wolves will also travel in these long, spread out lines. Well, they'll just basically outflank the prey, or they'll chase it from one side, and they'll be chasing it into more wolves on the other side. And so they're really, really intelligent hunters, and really the prey often stand no chance. And the last example that I want to give today, and also I'll include a video link of this really interesting example, is this evolved interaction between these bottlenose dolphins and hunters in Brazil. These fishers in Brazil have basically learned to work with these bottlenose dolphins to catch the fish that are called mullet. And so the fish will come up stream every year around the same time, and the dolphins will hunt those fish for their food, and the fishermen would like to catch those fish as well. And basically, what has happened is that over the generations, the dolphins have learned that if they push as a group the mullet into the fishermen's nets, they will catch the fish that are not caught in the net, or when the fishermen catch the fish, they'll throw some back to the dolphins. And so it's really interesting how this has actually evolved over many, many years, many generations, where the fishermen have taught their sons to do this, and the dolphins have taught their offspring to do this. And so it's really this cool, evolved, evolutionary relationship between two different species working towards the same goal. And lastly, I just want to put up this predator and prey comparison chart, where if we look at prey on the left and predators on the right, when we look at eyes, we have on the sides of the head for the prey and facing forward for the predators. That means that they'll have peripheral vision, where the predators will have binocular vision, which we have binocular vision, by the way. The peripheral vision might be useful for avoiding things, but not as good as finding distinct details and for analyzing distances. You'll get a wide field of vision where you'll get a narrow view here. So it's just trade-offs depending on lifestyle. Um, Prey will have teeth that are more adapted for grinding, right? Because usually they're going to be herbivores. Whereas predators will have sharp teeth for tearing. You'll have a jaw that moves side to side if you've ever seen like a cow eat, right? Where their jaw is moving side to side, or a deer. Whereas predators have a jaw that moves up and down, right? To chew large chunks of meat. And prey usually have smaller brains, whereas predators have larger brains because the energy that they're getting from their food is less and that can't support a larger brain. Whereas predators will be eating other organisms that are other animals, and that they will be able to support a larger brain. And so, really, this is just a comparison chart between predator and prey. And I might put something up on the exams, just saying, okay, if give you an organism, its eyes are facing forward, has binocular vision, has sharp teeth for tearing, would this be a predator or a prey? You would know that it would be a predator. And so that's just what I'm looking for. And it's sort of a short one today, but I hope you enjoyed it. And feel free to ask me any questions, and also look for that video about the dolphins and the hunting.